Hello everyone, I am Mayank and welcome to a video on Exploratory Data Analysis or EDA. In this session, we will dive into the essential techniques for understanding and visualizing your data. So EDA is the first step in data analysis, helping you uncover patterns, spot anomalies, test hypotheses, and check assumptions. So we will explore key tools like summary stat, data visualization, and correlation analysis, feature engineering, like this. By end of this video, we will equip with you the skills to transform your raw data into actionable insight, setting a solid foundation for further data modeling and decision making.
Craving a career upgrade? Subscribe, like, and comment below. Dive into the link in the description to fast-track your ambitions. Whether you're making a switch or aiming higher, Simplilearn has your back.
But before we begin, if you are planning to start career in data science, check out the Caltech postgraduate program in data science from Simplilearn, ranked as the top PG data science program by AIM in collaboration with Caltech, CTME, and IBM. This program is equipped with the essential skills and tools, including Python, machine learning, Tableau, generative AI, ChatGPT, and many more. So learn from industry expert through masterclasses taught by Caltech instructor and IBM expert. Join our comprehensive program to gain hands-on experience and advance your career with cutting-edge knowledge and expertise. You can find this course link from the description box below and the pinned comment. So without any further ado, let's get started. So hello guys, welcome to this demo part of this video. So here what I will do, I will go to new, then Python 3 file. Then here I will give it the name called Exploratory Data Analysis. Basically we have one dataset file of roller coaster basically. So we will be using that, and you can download that file from the description box below, from the below link, drive link. Okay, so we will be doing some small basic function using Python, and later on we will make some good charts. Okay, we will remove duplicates and all, we will do all that thing. We'll do data preparation, we'll do feature engineering. Okay, and we'll remove the duplicates, we'll check for the duplicates, we'll make charts like histogram, KD blocks, box plot, and like many more similar to that. Like heat map, will make scatter plot, group by comparison. Okay, we all do that, right? So just stick with me and you can write side along with me this code. Okay, so let's start with importing pandas first. I guess everyone know what is pandas and numpy. Fine. As np, then I will import numpy as np. Why this is np and pd? Sorry, my bad. PD is here because I don't want to write again and again this pandas, this numpy. So basically I can write this is small version. Okay, yeah. So if you guys don't know what is panda, so panda is very popular library for working with data. Okay, its goal is to be the most powerful and flexible open source tool. Okay, so it has these that goal. So data frames are the center of pandas. And what is data frame? A data frame is structured like a table or a spreadsheet. Okay, the rows and the columns. Okay, whereas NumPy is an open source Python library again that facilitates efficient numerical operation on large quantities of data. Okay, so there are many functions in NumPy as well. Those we can use in the pandas data frame. Got it? So we'll import one more dot pyplot dot pylab, okay, as plt. Okay, there is one more library, matplotlib, for plotting the graph, and there is one more, import seaborn as SNS. So what is Seaborn? Seaborn is again the Python data visualization library based on matplotlib. Okay, it provides a high level interface for drawing attractive and informative statistical graphs. Okay, then I will write here plt dot style dot use, will write ggplot. Got it? ggplot. Fine. So yeah, let me run it. So what is ggplot? So ggplot is this is an open source data visualization package for statistical programming. Okay, so yeah, you can say, or a general scheme for data visualization which breaks up graph into semantic components such as scales and layers. Okay, matplotlib.py. Okay, it's pylab p. Okay, yeah. So now we will import our data set. Df means data frame. You can write any word of your choice. Then pd, again pandas dot read underscore csv, used for reading csv file. Okay, excel files. Got it? Then here I will write my this coaster dot csv. Okay, I'm not writing any path because my this data set is here itself. Coaster c coast. This is coaster.csv. Okay, if you have your data set in another location, as in like in C drive, D drive, or whatever, okay, you can give that path. Okay, let me run it. Yeah. So now we will do some data understanding. Okay, we'll see data frame shape, head and tail, data types, and describe like small function we will use. df dot shape. Right. So we have 1087 rows and 56 columns in our data set. Okay, then we will see df dot head 5. So df dot head means it will give me top 5 rows of my data set. Okay, you can see 1 2 3 4 5. Okay, 5 rows and 56 columns. Here 56 columns, but we have 1087 rows. Okay, so we have coaster name, length, speed, location, status, opening date, type, this. Okay, we will do we'll make some graphs using these columns. Okay, and there is one more df dot tail, again last 5 rows. So df dot tail gives you the last 5 rows. See 1086 1085. Okay, and if you want to see full data, it is here. Okay, 0 to 1086. Fine. Yeah. So we have one more df dot columns to check all the columns. See, coaster name, length, speed, location, status, opening date, type, and these all are my columns names. Fine. So we have one more data types. Actually, we have like many data types, but let me show you some important ones, or you can say some of the basics ones. Okay, so df dot d types. D types means data types. Coaster name is object type, length object, and inversion is float. Okay, we'll check inversion. Where's inversion? Yeah, float type. Okay, then everything is object, and year introduces int, numeric one, and latitude float. Okay, so basically we have 3 types: float, int, and object. Okay, then what we will do? Let's just quickly check this. Describe. Okay, so what is the count of this inversion? 932. Okay, it won't include any what is it, empty cells. Okay, it won't count empty cells, right? Mean of this particular table, then standard deviation, then mean, minimum value 25%, 70%, 75%, and max. It will describe you all this. Okay, and there is one more df dot info to get the info. See, coaster name 1087 value non-null object, then length 953 non-null. Okay, like this. Yeah, So now moving forward, what we will do? We will do data preparation. Okay. What comes in data preparation? Like dropping irrelevant columns and rows, which we don't want. Okay. Then second thing is identifying duplicates columns. Then third is renaming columns. Then we will do some feature creations. Right. So if you want to drop a column, okay, how you can drop? So you have to write just df dot drop. First I will give here hashtag data preparation. Okay, yeah. So how you can drop a column? Okay, df dot drop. Then here I will write opening date comma axis equals to 1. Okay. Opening, okay, axis spelling is wrong. Instead of this, okay. Maybe what is the opening date? Okay, O is capital here. Instead of this, you can use double equals to. Okay, axis is not defined. My bad. So what you have to do, you have to give this here and you have to put it here. Yeah. Again, axis is not defined. Yeah, fine. Okay. So as you can see here, first I will show you this. Question name, length, speed, location, status, and opening date is here. Fine. So if you will go here, question name, length, speed, location, status, nothing, opening date is there. Right? So this is how you can drop a table. Fine. For a while I'm making it as a comment. Maybe in future upcoming, making graph, I need this. Okay. So yeah. So I will write here df equals to df question name, comma, location, then comma, status. Then here I will write manufacturer. Fine. Then again comma. Then I will give here year introduced, then comma, latitude. Wait, I will tell you why I'm doing this. Then longitude, latitude, longitude. Then I will give you type main. Okay. Then opening date clean. Fine. Then speed into in meter per hour. It is right. Speed into meter per hour. Okay. Then comma. What else? Then height, foot, inversion, clean, comma, g-force, clean, dot, copy. Yeah. Fine. So here I will write, okay, type in. Okay, one more mistake is here. Fine. So now what I will do, I will write here opening date clean equals to pd2 dot date time df opening date clean. Fine. What happened? So what does this dd.toDateTime2. Okay, so it converts argument to date time. Okay, so this function, you can say, converts a scalar, array like, or series or data frame, dictionary like, to a pandas date time object. Okay, so now let's rename the columns. Okay, then to for better things, df equals to df dot rename columns equals to coaster name, then poster name, comma, year introduced, then year introduced. Okay, opening date clean to opening date. Okay, then I will write as speed immutable r, then I will write caps speed underscore immutable r. Got it? Then height into foot, I will write it as should be capital. So why I'm writing this? Because this is a very good practice as a professional way, as a data analyst or as a business analyst, whatever you are working on machine learning projects or whatever the thing. So this is a good practice. Okay, so inversions clean, then it should be like inversions, then g-force clean to g-force. Fine, let me run it. Okay, now let's check the column. Yeah, so now you can say our column name is changed. Fine, so I will write this NA dot sum. So what does this is NA dot sum do? So is NA function returns a boolean value of true if the value is NaN and the false otherwise, and the sum function returns the sum of the true values, which equals to the number of NaN values in the column. So here we have 0 NaN, here same, this status 213, here 217, 5, height foot is 916. Okay, so now what we will do, we will write here df dot location df dot duplicate. I told you in starting will duplicate it. Okay, so question name, location, status, okay, it's duplicated now. Okay, so now what we will do, I will check duplicates for the question name. So you can write df dot go loc, then df dot duplicated and subset equals to poster name, then dot head. Okay, head of 5. Now everyone know, right, what this head does. Okay, yeah, so here you can see, so these are duplicate, okay, of the question name, right? Why? Because you can just check the type and wood and all. Fine, so now checking with an example duplicate, let's check df dot query question name equals to crystal. Now you will get beach cyclone. Okay, I took this crystal beach cyclone. Fine. Then run it. So now you can see 39 and 43 are the same. Okay, everything is same. So this one is duplicate. So now what I will do, I will write here. Just let me give some space. Yeah. df dot columns. Then I will write here df equals to df dot location. Then df dot duplicated subset equals to coaster name, then location, then opening date. Okay, dot dset index, then drop that. Okay, so now what we will do some feature understanding. Okay, so now we will do some feature understanding. Okay, so in this we will plot some feature distribution like histogram, KD, box plot. Okay, for that I will write here df year introduced. Okay, then I will write value counts. So now what I will do, let's create bar chart. Okay, ax equals to df year introduced dot value counts. Okay, then dot head 10 max I need, then dot plot kind equals to I need bar, then title is top. I like what should we give? Top 10 years coasters introduced. Okay, then I will write here ax dot set x label. Then I will write here year introduced. Okay, then I will write here ax dot set y label, then count. Okay, let me run it. Okay, unexpected character after line continuation. Okay, we can remove this as well. Unexpected intended. So now let me run it. Yeah, so this is our bar plot. Okay, so this is how you can create bar plot using your data. Okay, so a bar plot is one of the most common types of graphics in this data visualization or EDA. It shows the relationship between a numerical and the categorical variable. Okay, so each entity of this categoric variable is represented as a bar. Got it? So now let's do some more. So what let's make a histogram class. Okay, histogram. So for that I will write ax equals to df speed multiple r, then plot kind equals to histogram, then comma, I will write bins here. Okay, bins equals to 20, then title equals to coaster, speed, okay, meter per hour, then ax dot set x level is speed meter per hour. Okay, forgot to give this. Okay, yeah. So a histogram displays numerical data by grouping data into bins of equal width. So here each bin is plotted as a bar whose height correspond to how many data points are in that bin. So bins, you can say, are also sometimes called the intervals or classes or buckets. Basically, it's the same. So here for this much is the bin. For this much is the bin. So this is like that. Okay. So now let's create KD plot. So for that, it's very simple. AX equals to DF. Then I can write here speed in meter per hour. Then plot kind equals to KD, comma, then title. I can write anything, coaster, speed, then AX dot set X level, speed, okay, meter per hour. Yeah. So KD, what does KD means? A kernel density estimate. This plot is a method of visualizing the distribution of observation in a dataset, analogs to a histogram. So KD represent the data using a continuous probability density curve in one or more dimension. Okay, in one or more dimension, that curve. Fine. So now let's do some feature relationship. So in this we will make scatter plot, heat map correlation, and pair plot. Okay, or we can also do some group by comparison. Fine. So now let's first make scatter plot. Okay. So df dot plot kind equals to scatter, comma, x equals to speed meter per hour, comma, y equals to height in foot. Fine. Then comma, let's give the title equals to coaster speed versus height. Fine. Then plt dot show. Okay, some error is there. Speed meter per hour. Okay. Okay, S should be capital and H should be capital. Yeah. So this is scatter plot. Speed versus height. This is speed versus height. Okay. If the I can see here height is directly proportional to speed somewhat, because if you can see the 350's speed is then 120 kilometer per hour. No, it's not like that. Okay, fine. So scatter plot identifies the possible relationship between change observed in two different sets of variables. Here the variables are height and the speed. Okay, it provides a visual and the statistical means to test the strength of relationship between two variables. Fine. Now let's make one more to give you better idea. Okay, with legend. Now I will show you with sns dot scatter plot, then x equals to speed meter per hour, comma, y equals to height into foot, feet, whatever you can say. Then hue will be there, then year introduced. Okay, then data equals to df, then ax equals to set title, set title, then coaster, speed versus height, then plt dot show. Yeah, so now you can see, so this color, the light color, let me zoom it. Okay, so this color we have some here which are introduced in 90s. Okay, and this color which are introduced in 1925, and these color which are introduced in 2000. Okay, so you can see like this as well. So now let's make pair plot. Okay, it's look amazing. So let me write sns dot pair plot, then df comma variable is equals to, I need year introduce, then speed meter per hour, comma, that should be capital, height, foot. Just remember the spelling, okay? It's case sensitive. Inversions, comma, g-force, okay, comma, hue, I will put what, okay, I will put type main, fine, then plt dot show. Okay, let me run it. Okay, some error is there. Here introduced, y will be capital, then same here. So that's why I'm saying just remember the proper spelling. Again, some error, sorry, my bad. Inversions is inversions. Now let me run it. Okay, again some error is there. Okay, what inversions? Okay, let me check here while renaming. Inversions only. Okay, fine. Inversions. Let me paste here, but nothing changes. Let me check again. Okay, some error is there. Wait. So yeah, you can see it's running fine. So after this, what I will do? So what is the pair plot? So pair plot function allows the user to create, then an axis grid via which each numerical variable stored in the data is shared across the x and the y, okay, in the structured column. So this is how, see, type in wood, other and steel. This red one is wood, other are the blue one, and the purple are the steel one. Okay, the different format. Okay, now let's create the last graph, which is heat map. Okay, so let me write df correlation equals to df here introduced, comma, speed meter per hour, comma, height into foot, again it will be the same, comma, inversions, comma, g-force, then drop na, then correlation, okay, df minus correlation. Okay, here introduced, I is capital, yeah. So this is correlation values of all the things, right? So now let's write sns dot heat map heat map, then tf_corr, comma and not will be true. Okay, now let me run it. Yeah, so to create heat map in Python, so you can use this, okay, Sealborn library for this heat map. So this function takes a data frame, as an input and generates a heat map type of things as the output. Okay, so this is how you can perform EDA using any dataset, or you can show your data or insights with a beautiful representation using graphs and all like this. Fine. So with this, we have come to the end of this video. If you have any question or doubt, please reach out to us using comment section below. Our team of experts will help you as soon as possible. Thank you and keep learning with Simplilearn.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.